Good morning, beautiful people. I'm going to go ahead and go over the quiz review for you. So I'm just going to go through this. You can follow along with it, check your answers, whatever you need to do. But again, just pause as needed, rewind, whatever it is. Okay. So we already did number one. I helped a lot of people out with number one in class, so I'm not going to go over that one. I'm also not going to go over 3B because 3B we did on the warm-up on Wednesday. So if you check your warm-up from Wednesday, that was the first warm-up problem. I'm also not going to do number 4 because number 4 was also a warm-up problem. On Wednesday, it was the second question. So that's why I have those crossed off there. So I'm not going to do number 1, 3B, or 4. Okay? So let's go ahead and get started with number 2. Determine which recipe would be spicier in the tomato sauce. So if we look at recipe A, we're going to need some tables because we're going to be comparing. And we need a table for B. So if I'm adding in peppers and tomato sauce, that's what I'll make my table. Peppers and sauce. Peppers and sauce. Okay, so 6 ounces of peppers, 15 ounces of tomato, 7 ounces of peppers, 20 ounces of tomatoes. Now, I want my sauce ratio to be the same, so I need to think of a number that 15 and 20 both have in common. If I do out the factors, then it would be 15, 30, 45, 60. For 20, it's 20, 40, 60, so they both have 60 in common. I know that 20 times 3 is 60, so 7 times 3 is going to be 21. Remember, whatever you do to one side, you have to do the other. 15 times 4 is 60, so I have to do that to the side, so 6 times 4 is going to be 24. So now that the ratios are the same, the sauce, the denominator is the same of sauce, I can look at which one has more peppers, which will determine which one is more spicy. So 24 is greater than 21. So recipe A will be spicier. Lola. Sorry, I'm talking to my dog. Okay. Next, we're going to go ahead and solve some proportions. So I'm going to first simplify. If you can simplify, I always suggest simplifying. Top and bottom for 24 and 40. They both can divide by 8. So I get 3 over 5 is equal to t over 30. Well, now I can see that 5 times something gives me 30. That's 5 times 6. So whatever I do to the bottom, I have to do to the top. So 3 times 6 is going to be 18. So t is equal to 18. Okay. I'm going to go ahead and do C. So you could have done the cross product and your answer would have been the same, but I'm just going to show you how to simplify. So let's try and simplify this first. They both can be divided by 2. They both can be divided by 4, but they also can be divided by 12. And you want to try and divide by the largest number. Okay, so 24 divided by 12 is 2. 36 divided by 12 is 3, is equal to 28 over x. So I have to look at the relationship here. If there is one, there is. 2 times 14 gives me 28. Whatever I do to the top, I have to do to the bottom. 3 times 14 is going to equal 42. So whatever method you did, you should be coming out with the same answer. Okay, like I said, we're going to go ahead and skip 4. Okay, because I already did that on the warm-up. So let's go ahead and look at 5. So Jack, Susan, and Mario set up the following proportions to solve for x. The first thing is to see who set up the proportions correctly. So first off, $12 is for 1 gallon, and we want to know what 0.25 of a gallon is going to cost. So whenever you're setting up proportions, your ratios need to be equal. Okay, meaning that from on top, it needs to be money, money. Bottom, gallons, gallons, whatever you're talking about. So if I look here, this is money, but this is money. Okay? So they're not across each other. That's not good, right? Same thing with the gallon. If I was just to look at the gallons need to be side by side, and they're across, which is not good. Same thing right here. They're across. That's not good. Bless you. If I look here, those are side to side. So that's good. And then we have money, money. That is also good. So Mario set it up correctly. Okay, so now we're going to use that proportion from Mario to solve for the price of 0.25 of a gallon. 0.25 of a gallon is just 1/4 of a gallon. So if you hear me say 1/4, just know I'm talking about 0.25. So we had $12 for 1 gallon is equal to X dollars per 0.25 gallon. So you can go ahead and just cross multiply. 12 times 0.25 is going to give us 3. And 1 times X is just going to give us X. So X is equal to 3. But we need our units. So is that 3 gallons or $3? We were trying to find the dollar amount. So this is $3. So look over on the table. We want to go ahead and fill that in. Okay. Part C says once you find the price of 0.25 gallons, use proportional reasoning to fill in the rest. So if 0.25 is 3, if I double 0.25, that's going to give me 0.50, then I have to double the price. That should be 6. And then if I know that 0.25 is 3, if I add 0.25 to 50, I get 0.75, so then I have to add 3 over here, so that should be 9. Okay, so then 1 gallon is 12, so 3, 6, 9, 12. Now we jump to 2.5. Okay, so we can keep adding, but I do want to just do a table real quick. So we know that 12 is 1, and we want to know what 2.5 is, how much. So let's cross multiply. 1 times X is X. 12 times 2.5 is going to give us 30. And again, this is money, not gallons, so this is going to cost $30. Okay, for 5 gallons, we can just go ahead and multiply, right? I know that I multiplied by 5, so I need to multiply by 5. So 12 times 5 is going to give us 60. Okay. Last 2 questions, we're going to be doing some unit conversions. So we are going to use this table right here to help us out with numbers 6 and 7. So Lisa participated in the 10-kilometer run last weekend. How many feet is that? So let's start with 10 kilometers. We know that 10 kilometers, we can see right here that 1.6 kilometers gives us 1 mile. So now we can cross off those units there. Now we need to go from miles to feet. So 1 mile, I can see, is 5,280 feet. Okay, and now we can cross off mile with mile. So all we're left with is feet, and we just need to multiply. So remember, there's that invisible 1. So you're going to multiply everything across the top, which is going to give us 10 times 1 times 5,280 divided by, and again, this is feet, everything multiplied across the bottom. Okay, so 1 times 1.6 times 1, but again, you don't have to multiply by 1, so it's just 1.6. So if we put that into the calculator, 10 times 5,280, and then we divide by 1.6, you should get 33,000 feet. Okay, the U.S. average rainfall is 3.2 feet per year. Okay, feet per year. How much that is in centimeters per month. So we're going to be doing two conversions. We're going to go from feet to centimeters, and then we need to go from year to months. Okay, so let's go ahead and start with the feet first. So 3.2 feet per 1 year. So 3.2 feet, we know that in 1 foot, there's 12 inches. So that crosses off feet. Now from inches, we need to go to centimeters. And on the table, it tells us that 1 inch is equivalent to 2.54 centimeters. So I can now cross off inches with inches. And we're left with centimeters per year, but we want it per month. So how many months are in a year? There's 12. So 1 year has 12 months. So we can cross off year with year as well. So again, we multiply everything across the top, which is going to be 3.2 times 12 times 2.54 times 1. And again, this is centimeters. And then on the bottom, okay, we multiply across everything. 1 times 1 times 1 times 12, which is just 12 months. So if you put that in the calculator, type all that up, don't forget to divide it by 12, you will end up getting 8.12